Foundations of Amateur Radio. One of the unsung hero components of a software-defined radio is the AD, or analog to digital converter. Its job is to convert the analog signal that's coming in via the antenna into a digital signal that is processed by software. I've talked about the difference between analog and digital before, and many explanations talk about converting things into 0 and 1. There are a few steps before that. Imagine a row of identical glasses, let's say 8. Grab a jug of milk and pour it into the first glass. Keep pouring until it's full. Now do the same to the second glass. Rinse and repeat until you either run out of milk or run out of glasses. You now either have a row of glasses full with milk and some spilled all over your desk, or you have some full glasses and some empty ones. Now, if you were to mark a 1 on your logging paper for every full glass and a 0 for every empty glass, you'll end up with a row of 0s and 1s. Essentially, you've converted an analog signal into a digital one, and in effect, this is how an AD converter works. Each glass represents effectively what's known in computing as a bit. Grab 8 of them and you have a byte. I will point out that this is just one example of an AD converter. There are many others. You may have noticed I've skipped over some interesting things here. For example, what happens when you spill your milk all over the desk? Or what happens if you don't completely fill a glass? This is the bit where the action is. So let's look at that. If you've ever overdriven a microphone or a speaker, heard of clipping or distortion, those are all equivalent to spilling milk all over your desk. The takeaway is that there is an indeterminate amount of milk and no place to store it. So your row of glasses says all full, but you and I both know there is some spillage. This is lost information. We don't know if there is a droplet spilled or a whole ocean spilled. So one consideration in picking an AD converter is how to deal with high signal levels. You may need to either increase the number of glasses, or bits, or you may need to decrease the signal before measuring it. Another interesting thing is what happens at the boundary between full glasses and empty glasses. If you pour one glass full and run out of milk, you're good to go. But the reality says that you'll start pouring the next glass and you'll run out, having a glass that's only half full. Or is it? Is it half empty? How do you know? Is this glass represented as a 1 or as a 0? You could create a row that's twice as long with glasses that are half the size, and at the boundary you'd have a more accurate idea. But you still have the same issue. Is the glass that you filled only partly half full or half empty? There's more to come, but the basic idea of converting an infinitely variable signal coming in from your antenna into something used by software is a big part of a software-defined radio. I'm Ono, Victor Kilo 6, Foxtrot Lima Alpha Bravo.